Hey folks, welcome back. So in this lesson, we're going to do a Lambda walkthrough, and actually we may do a couple walkthroughs in multiple lessons. When I first started with Lambda, I found that it was such a paradigm shift that I had trouble visualizing what was going on with Lambda. As an AWS solutions architect, I'm used to looking at my resources. I'm used to looking at VPCs and EC2 instances, S3 buckets, subnets, and security groups. Well, with Lambda, that's all handled for you by AWS, and it's great in that aspect, but it makes it difficult sometimes to visualize Lambda. So we'll keep stepping through Lambda and just ramp up our knowledge and just keep building up and visualization of what Lambda is doing for us. In the DevOps doctrine, let's click Lambda walkthrough, and let's take a look at our diagram. So we have our event sources, and we've seen that. That can be a number of event sources. It can be S3, DynamoDB, Kinesis streams. And when events occur to our event source, and I'll use the S3 scenario, a file is uploaded to S3, that's our trigger. It's going to trigger our Lambda function. Lambda function can do any number of different things, perform operations, and produce output to downstream resources. And we'll see that it interacts with CloudWatch. We'll take a look at the CloudWatch stats in these lessons. Now, one thing we didn't talk about yet was AWS SAM, Serverless Application Model. So AWS SAM is an open source framework you can use to build serverless applications on AWS. It consists of the AWS SAM template specification that you use to define your applications, and also the command line interface for SAM that you use to build, test, and deploy your serverless applications. And it's closely related to CloudFormation, and that's a good way to think of SAM. You can, just as you would with a CloudFormation template, define your serverless applications using SAM. Now remember our requirements. We need to provide our code, and actually in this first walkthrough, the code is going to be provided for us. We need to provide the memory specification for our Lambda function. We specify the execution timeout, an IAM role, and there's an event source mapping, which we haven't talked about yet, but basically we have our event source. Now realize we could have multiple Lambda functions. Well, the event source mapping is simply a mapping of our event source to one of our functions. It's basically saying we have our event source. When there's a trigger action, which Lambda function do we run? And it's that simple. All right, so let's create a function, and we're going to use some of the AWS Lambda provided examples. We'll just keep ramping up our knowledge base and the complexity of what we're doing. So let's click Create a Function. All right, we can author from scratch. AWS Lambda has, as you see, many blueprints, different kind of Lambda functions we can run here, and serverless application repository. Again, we have many options here, and it's worth browsing through this. It's always good to know what tools are available to meet your use cases. Let's author from scratch. Now, in reality, we're going to let Lambda help us a little bit here. All right, let's give our function a name, and look at our runtime options. They are numerous. And let's choose Python 3.7. Now, remember, we need an execution role. We could choose an existing role, create a custom role, but let's choose create a new role from one or more templates. And let's give that a name. And remember, you can attach policies to a role, and that's what this is for. But note this new role will be scoped to the current function. To use it with other functions, you can modify it in the IAM console. So this is a pretty basic role, and it's going to meet our needs. So we don't need a policy. Our Lambda function will have the necessary execute permissions. So let's click Create Function. Now note that we are provided with some code here. There's our handler. Now these handlers may look different in different languages, but Their construction is essentially the same. Our Lambda function is event triggered and some context information is passed in. And our simple function, again, this is a very simple one, just a message, hello from Lambda. And bear with me, we will get more complex as we move through this section. And let's just take a look at some other things available. Environment variables. So these are key pairs accessible from your function code. Tags. There's the execution role that we created on the last page. Basic settings. Memory. Remember, 128 meg to 3008. There's our execution timeout. Remember, the max on this is 300 seconds. And we can put this in a VPC if we so choose, but we're not specifying any resources. AWS does that. Some debugging and error handling. So let's test this out. So we're creating a new test event template. We need to give our event a name. Now this is a sample event template. We have key pairs. We could change these. And this is in JSON. But if we did change these, we would have to update the sample code. So let's just leave this and create. Okay, so we've created our Lambda function. We can now change its code and configuration. Choose test to input a test event. Again, it's event driven, and this just simulates an event. Let's go ahead and test. All right, execution succeeded. There's our result. There's how long it took, how long we were billed, memory used. And here's some output information. These requests just have IDs, and a lot of this information is up above. And also there's a pane for our execution results, similar to what's here. All right, let's just run this a handful of times. And just notice some things changing, like the duration. The request IDs, of course, change. And what this is going to do is build up some data. Remember, this data is being recorded in CloudWatch. And to view that data, we can click on Monitoring. Invocations, duration, of course, how long it took to run. There's a maximum one. There's the average. Errors and availability. We had no errors. 100% available. Throttles, and this is the number of times that execution failed due to concurrency limits. We didn't have any problems there. Iterator age. This is for streamed event sources. This is the age of the last item in the batch when Lambda receives it and invokes the function. And then dead letter errors. The number of events that Lambda attempted to write to a dead letter queue but failed, and nothing to report here. Let's just go back to our configuration. So as you see, as simple as this is a full-blown Lambda function. So in this lesson, we just ran a simple Lambda function from the management console just to keep ramping up our knowledge of Lambda and familiarize ourselves with the Lambda management console. So let's keep ramping up our knowledge and escalating the difficulty of the functions we're looking at. Please join me in the next lesson.